Question 3. Let S be the unit sphere inside R3. 3a asks to show that S is path connected. So let's do that. So to do this, I'll break up the work into two cases. So we begin by letting vector x and vector y, or sorry, vector x and vector x prime rather, be from the sphere S. Case 1, x is not equal to negative x prime. So what's that meaning? It means x and x prime are not diametrically opposite. And you'll see later why we have to break it up into two cases. But for now, just bear with me. Okay. So what does this mean? I have a sphere. Okay. I have a point x. That's my point x. And I have a point x prime. These 2 points are not diametrically opposite. And what I want to do is I want to find a path that starts at x and goes to x prime. So the first thing I'll do is I'll consider a path. I'll consider a path P, which goes through the sphere. And here's what I mean. P of t, that's a P, is defined to be x naught plus t x1 minus x naught, y naught plus t y1 minus y naught, comma, z naught plus t times z1 minus z naught. So this path P is a straight line path that goes from x to x naught. Is a straight line. It's a straight line, which is a path. It's a straight line going from x to x prime. But the problem is that this path goes through the sphere. That's not what we're interested in. What we're interested in is a path that goes on the surface of the sphere. So to fix the problem, what we could just do is then normalize every point inside the path P. So in that way, when we normalize it, everything will have length 1, and therefore everything will be on the unit sphere. So consider a new path. Consider a new path Q, which normalizes P. So in other words, Q at time t will be equal to PT divided by this. And since I'm dividing by the norm of all the vectors, that's always going to be an S. But we have to be careful that PT is never equal to 0, because we can't divide by the 0 vector. 0 vector has length 0. So we'll quickly check it's well defined. Or instead of writing well defined, check PT is never equal to 0. And we know that PT will never be equal to 0 because the points I picked, x and x prime, are not diametrically opposite. If they're not diametrically opposite, then the straight line joining through them will never have any reason to go through the origin. So let's write that out. PT is not. This is because x and x prime are not diametrically opposite. So the straight line path never goes through the origin. So therefore, Q is well-defined. It is a well-defined path from x to x prime. And this is specifically by case 1, by assumption of case 1. So that finishes case 1. And quite obviously in case 2, we're going to then consider what happens when x and x prime are diametrically opposite. So that's case 1, case 2. X is equal to x negative of x prime. Did I write it correctly? Yeah. So in other words, x, x prime are diametrically opposite. So let's draw the sphere. Okay, so let's say that's your x. Diametrically opposite would mean the x prime is there. So the trick that or the technique we used last time wouldn't work directly. But what we could do instead is that we could consider a new point, x double prime, which is not diametrically opposite to x nor x prime. And by case 1, there would be a path from x to x double prime, and there'll be a path from x double prime to x prime. And if we did that and took the concatenation, that would work too. So let's go through those details. Case 2. Let x double prime on S double prime not be diametrically opposite to x nor x prime. So by case 1, there exists a path P1 from x to x prime, and there exists a path P2 from x double prime to x prime, and these paths P1 and P2, both of them have a domain of 0, 1, and both of them have an output on the surface of the sphere. So what remains to be done is take the concatenation. So let's do that. So define Q, path Q to be like this. P1 of 2t, and that's when 0t half, and P2 of 2t minus 1 when we go from half t to 1. So a few things. Why did I have to define my qt like this? The reason is because the domain of t has to go from 0 to 1. So that's the reason why here I have to have 2t, because it's going to end off at 1/2. And here I need to have 2t minus 1 because it goes from 1/2 to 1. That's first. Second, we have to check that this is well defined. And specifically, I defined this function at t equals to 1/2 at 2 different points. So you have to check at t equals to 1/2, P1 of 2t is equal to P of 1, and that's just x double prime. And P2 of 2t minus 1 is equal to P of 0, sorry, P2 of 0, and that's just also going to equal to x double prime. So this function is well defined. So therefore, Q 0, 1, S is a well-defined path. Path from x to x prime. So now that both cases are settled, we get to the natural conclusion. Therefore, S is path connected. And that's it for question 3a.